In this video, I'm going to explain what GraphRag is, why you might use it, so the situations it works well and doesn't work so well. We're going to see how to use it using Microsoft's Python package and how you can load it into Neo4j for visualization. And finally, I'm going to show you a Streamlit dashboard where you can summarize a whole book, in this case, A Christmas Carol, and compare the output between local and global search and standard RAG. For the rest of this video, I'm going to assume that you know how RAG works, but if you don't, I've got another video which explains what RAG is in a visual way, so check out this video here if you haven't. Microsoft released GraphRag earlier this year, which is a new method for retrieval augmented generation that is improved in several ways. Normal RAG, what I'm going to call baseline RAG, can struggle to connect the dots between bits of text. So that means if you've got multiple documents, it can struggle to connect those pieces if they're not in the retrieved context. It's got no global visibility of all the texts. So if you're asking global questions like summarize this book, or what are themes in the book, or describe the main characters, those types of questions normal RAG will struggle with because it doesn't have access to the whole corpus of text. There's also no semantic understanding of the text in that it can't connect bits of text if they reference the same person or the same topic. What it does is it constructs a knowledge graph to represent the text corpus, where each chunk is a node, but also there are additional entities within there that can be used to link parts of text and representing concepts like documents. This method, I think, will work quite well when you haven't got a massive corpus of text, but when you've got a smaller corpus of text where you want a higher quality of output, and that corpus of text isn't going to change too often, as it doesn't necessarily scale too well and it can get quite expensive. Because it has to create hierarchical summaries, it ends up calling a language model frequently to produce those intermediate summaries, so it can get quite expensive. It can also be slightly slower to query, especially if you're doing what they call the global search, which will take into account all of the nodes in the text corpus. So there are actually two parts to what Microsoft's introduced. There's the process they use to ingest the graph, and then there's two querying strategies that they introduce, local and global search. So let's talk first a little bit about how they create the graph. They've produced a library that you can use, and we use later on when you have a look at the code, to generate the graph for you based on your corpus of text. But briefly, what this is doing is it's doing the same thing as naive RAG. It's taking your documents, chunking them up into individual text chunks. It's then extracting entities from those text documents, so people, places, concepts like that. And then it's also producing summaries on top of each of the text chunks to be able to then create community summaries and community's answers. So that means you've got clusters of nodes across the entire graph that can be used to tie together when you need to scan across the entire text corpus. So that's how they do the ingestion. Next, the two types of search, local and global search. Local search is more similar to naive RAG. It searches across all of the nodes, and so that includes the text chunks, but also the people, places, those entities that it's extracted, and finds the most similar ones. Once it's found the most similar ones, it will then use connections in the graph to find other promising nodes to be able to use as part of the context that you can use in the same way as naive RAG. Global search is a little different in that it will search across the community summaries, which are the summaries of summaries, if you like, across the entire graph. And it will then rank these summaries of summaries and take the top n to use in your context during the search. So that's a very high level summary of what GraphRag is. Let's take a look at what a graph will look like when we have ingested it from the command line using Microsoft's tool and then transferred it into Neo4j so that we can visualize it more easily. So for this test, I've ingested A Christmas Carol by Charles Dickens, which is a classic novel. Let's now have a look at what it's going to look like when we open it in Neo4j. I'll show you the code a bit later about how we do the ingestion. So let's open up the Bloom window and select all the nodes and all the edges to view. So we can see the whole graph that's been created by Microsoft's algorithm. On the right, we can see the different node types, and there we go, there's the whole graph. And we can see all the different colors representing the different node types. The yellow ones, which are text chunks, so these are the same as your naive RAG when you chunk up the text into fixed sizes or whatever you're using for your chunking strategy. The light blue nodes, those are the entities that have been extracted. So those are people or places or concepts that are common between text chunks and can be used to connect those different chunks of text. The edges, these are all the relationships between those chunks. So it could be two concepts that are related or a concept with a text chunk, which means that if we retrieve one chunk of text that's similar to our query, we can then connect it to another chunk of text, which we can connect in turn to another chunk of text. So here, these are the community clusters. So these are the groups that have been created from the text chunks and where summaries are attached to them, which is used by the global search in order to be able to scan across the entire text corpus. And we can see briefly some of the edge types, which are belonging to a community or has finding, is related, those types of things. So it's useful to see it in this kind of setting visually, so we can see how everything is connected and see exactly what the algorithm is doing. And we can see just by scanning a few of the characters from the novel and a few events or related concepts. Next, let's take a look at the code that we can use to load the graph that's produced by Microsoft's command line tool, their Python package, into Neo4j to view it in this setting. Right, let's take a look at the code. So I've got the Streamlit app down here, which pulls everything together, and I'm running it asynchronously. So all three different RAG types are run at the same time, and I time them all so that we can see how well they're doing. And I do that with the asyncio library and create separate tasks and gather them all up at the same time, and then just display them in three separate columns. Let's first take a look at the traditional RAG, where we use the same book and I use the same prompt for the global and local RAG search so that there's as much consistency as possible. And what I do is I chunk up the entire book to store it in the vector database, and then look up the closest 8 chunks to the query chunk using this model, which is one of the top smaller models that I can run locally. And then this prompt will combine all of those potentially relevant segments into a single answer with the same criteria that I'm providing to the local and GraphRag. So that's what the traditional RAG looks like. And as with the other two, I'm using the same language model, which is GPT-4o in both instances. And we're using ChromaDB as our vector database, which I've found is the most convenient local vector database. For the GraphRag, we're using Microsoft's implementation to construct the graph. So locally, I'm having to extract it with these commands. So you can, after installing the GraphRag library with pip, you can then run it from the command line with Python. And so this will then create the graph and store it in Microsoft's format in the folder that you specify here. Because I want to be able to visualize the graph in Neo4j, I've then had to do some extracting of the graph to Neo4j, and I've followed the tutorial from this guy's blog on Neo4j's website, and I've taken it out the notebook and put it into a more functional format so that I can more easily extract and apply the method to any text that I like. And broadly what this is doing is just pulling the graph components from Microsoft and recreating them in Neo4j. So here we can see it, it's bringing in the documents, the text, the entities, the relationships. And so this file is just for doing the import, if you like, from Microsoft. And then I've got another file which executes the local and global search. So for the local and global search, there's one query here which is run against Neo4j, and this is searching predominantly against the nodes and then any linked related nodes from the associated communities. For the global search, there's two separate prompts. There's a map prompt and a reduce prompt because it's summarizing it in a hierarchical format from the ground up. And so it follows the typical map reduce algorithm, where we're using the map prompt against each community, and then we're using the reduce chain at the end to compress the information from each community. So this will only work at the moment for a single level. With larger graphs, it will become more hierarchical, and we would need to perform multiple maps and reduce stages. Right, so let's see it in action and see the two GraphRag methods for searching compared against Neo4j. To compare, we can view them on the Streamlit dashboard, and I can perform a search which requires access to the entire corpus of text to be able to work. It's a good way to demonstrate where Neo4j doesn't work so well. So I'm going to ask it to summarize the entire book, and we'll see what comes out the other side. So it's just loading. Right, here we go. So we can see that the local search results on the left has focused mainly on the ghostly visitations, which is a key part of the book. The Neo4j, which is the column in the middle, has not been able to generate a summary because it wasn't able to retrieve any relevant context. And the result on the right, which I think is clearly the best summary one, summarizes not just the ghostly visitations, but the core themes in the book as well, focusing on the transformation, the symbolism of the book, and concluding it as well. So clearly GraphRag's global search has performed the best here. It's also referenced multiple chunks of text, probably a significant number more chunks than would have been referenced by Neo4j, because otherwise you'd end up with too large a context. The other thing we're looking at here is that the local search has taken about 13 seconds and the global search has taken about 30 seconds. So the takeaway from this is that it can do things that Neo4j can't. It's not just a direct comparison, but also that it's much slower. Let's take a look at one more example. In this example, I'm going to search for who Scrooge's best friend is, which is a little bit of a trick question because the book is around how Scrooge has very few personal connections. So it's a little bit of a trick question that you'd expect a nuanced answer for. And as expected, the Neo4j or baseline rag hasn't been able to find any reference because Scrooge doesn't have a best friend. But both the local and global searchers were able to pick out that he did have a close relationship to his previous business partner, and then was able to go into some of the nuance about that. And the global search result goes into a lot more detail, the kind of thing you would expect more from an essay or a university essay, with appropriate references at the right times and a good level of detail. So there we have it. I hope that you should now understand a bit more about how GraphRag works and why it might be relevant to your problem. Hopefully you can see how you can use Neo4j to visualize the graph that's produced by Microsoft's tool, and how you can test out and compare the results interactively in Streamlit. If you like this video, please like and subscribe, and you can stay tuned for more content. Thanks.